Okay, the second one is residential energy storage system. So there are two kinds: the low voltage and high voltage. Basically, the low voltage operates at a single phase, okay, which is ideal for homes with lower energy needs. And if we talk about the high voltage energy storage system, so these systems utilize three-phase power, these are suitable for large homes or those with a higher energy demands. So first we learn about the low voltage energy storage system. Okay, the series called Helios series. So the rated output power for the system are 6 kilowatt and 8 kilowatt. Okay, if we look at the key features of the system, okay, so the system is IP65 rated, making it suitable for outdoor installation, flexible rate tariffs, okay, remote monitoring through application, okay, configurable AC and solar charging priorities via touch screen, okay, two channels output, the smart output and primary output. Basically, the smart output are those loads which we want to be disconnected at a certain battery percentage. For example, we choose 60% for this load disconnection. So at 60% the load, this kind of load will be disconnected, but the primary output or the primary load will be connected all the time and will be fed by the energy storage system. Parallel operation, so up to 6 units can be connected in parallel for enhancing the power for 6 kilowatt inverters. So if we connect six in parallel, so the maximum output power we can get is 36. It comes with a built-in Wi-Fi data logger for configuring with the home Wi-Fi and for monitoring purpose. The product appearance, here we can see a touch screen, okay, the status indicators, a DC switch, and the terminals for batteries, for from the power grid and load side, and for the PV panel. If we look at the screen, the touch screen, what we can see in that one, the PV information, the generation information, what PV generates, okay, the battery information, the grid information, and load side, like what how much load is connected to our system. Here we can see the main interface, the setting, and similarly the history. Here in the history we can see the alarms and warnings, the information of the system, and inverter mode, at what mode the inverter is working at that time. So these are some uh, icons which we can see in our touch screen. The next one is system configuration. Basically, the system has four basic components. The first one is the PV, the hybrid inverter, battery energy storage system, and utility grid. So we connect some loads to the system, which is off grid if it is connected to the inverter. If the load is directly connected to the grid, so that's on grid load. So there is no concern of the inverter or the energy storage system with on-grid loads, so it will only be responsible for off-grid loads. The product specification: rated output power 6 kilowatt and 8 kilowatt, which are the continuous and peak power ratings. Battery capacity ranging from 10 kilowatt to 35 kilowatt. Each battery module in this system is 5 kilowatt hour. The cell technology is lithium ion batteries. Efficiency is 93%. If we talk about the voltage, so that's depend on the uh, grid standards, which could be 220, 230, or 240. And similarly, if we talk about the frequency, it could be 50 or 60 hertz. The life cycle of the battery is 6000. Safety features: some hour current, over and under voltages, over temperature, okay, and some short circuit and overload protection. These are the integrated protection features of this system. Application scenarios for these systems are backup power, okay, energy independence, and cost saving. Parallel operation, as I mentioned earlier, so 6 units can be connected in parallel maximum. The capacity. for the system will be the rated output power is 36 kilowatt, while the storage capacity will be 215 kilowatt hour. So next we learn some setting of the system. Here we can see the charging modes of the battery. Okay, basically in the charging mode we want to use the system, for example the PV generation and the power grid. So which one we want to prioritize for battery charging? Okay, either it could be a power grid or solar panel generation. So solar first, that means solar will be responsible to charge the batteries, and if solar is not available, so the power grid will be responsible. In case of solar and AC, both are responsible to charge the battery at the same time simultaneously. And solar only, in this case only solar will charge the batteries, solar generation will charge the batteries. And if the power grid is available, but in this case the power grid will not charge the battery at any cost. The load side, how we want to feed the load, either from the battery, solar panels, or from the power grid. So these are the priorities. Okay, so priority, for example, in case of AC, we give the priority to the power grid to feed the load. Then it could be solar panels and battery. In case of solar first, so the solar is responsible for feeding the load. Then it could be battery or power grid. And similarly for the battery first, a battery are prioritized to feed the load. Then it could be solar panel or power grid. Okay. In the priority setting, so for in this case, basically it is designed for those where the prices are not fixed. For example, during the peak hours the prices are higher, and during the off peak hours the prices are lower. So we can set the time, for example during the peak hours are from morning 8 to 10 p.m. So during this time, if the prices are high, so we use our energy storage to feed the load. But if the for example if the prices are lower from 10 p.m. to 8 a.m. morning, so in this time we feed the load and charge our battery. So we can use the battery energy during the peak hours. So these are for the settings of the charging and discharging of the battery. Okay, so next we learn the monitoring system of a low voltage energy storage system. Basically, here we can see the energy flow diagram of the system, the solar power generation, state of charge of the battery, the load power, and the power purchase from the power grid. Okay, if you move to the next, we can see a graphical representation for our power. Either it could be grid power, power generation, state of charge of the battery, or battery power. So you can see this one for a single day, for a month, for a year, okay, for a total time when we install our system. The next one, if we further move into the details, okay, so we choose the date and the time slot. In that one we can see the rated output or generation power for the batteries. Okay, uh, the battery voltages, the PV voltages, the power grid voltages. Okay, and also we can for the battery we can see the state of charge, state of health of the battery, current of the cells, and voltages of the cells. And the main thing is temperature for our energy storage system. The next thing is alarm for the system. If there is any alarm or warning or error in the system, so we can see here what kind of alarm is there. So here will be a list. So further moving into the fault and alarm. Okay, so what we can see, we can see the occurrence time and the type. Okay, and the description of that warning or alarm or error. And description in here we can see the code for that alarm or error, and here we can see the status, either it is handled or not. Okay, on the load side we can set the output voltages and frequency. And similarly if we look at the energy storage machine setting, basically these are setting itself for the machine. Here is a case study for Hades series low voltage energy storage system. So there is a laboratory in Philippines. Okay, so they have installed a low voltage energy storage system. Here we can see the inverter and the batteries. There are four modules. Okay, so each module here is 5 kilowatt hour. So if we look at the quick facts, so the rated output power for the system is 6 kilowatt. Basically, the system is great tight battery backup system at this stage because the solar panels are not connected to the systems. If we talk about the storage capacity, which is 20 kilowatt hours, challenging address to the customer before installing the system or backup power. Okay, they require backup power, stable backup power, and there are a lot of power outage for that area. If we look at the future expansion plan, so we can add additional batteries and inverters in parallel, and also installing the solar panels. Okay. If you look at the payback period of the system, so for this system it's 6 years because there are no solar panels installed with the system, so it's only used for backup and during the power outage.